Hello and welcome back. Let's talk about graphing with polar coordinates. This is our second last video on polar coordinates. I'm going to be completely honest with you guys. I absolutely hate polar coordinates. So I'm glad that we're on our second last video. I guess we're only halfway through, but I'm glad it's short. We'll say that. I guess next video is a little fun because we'll be talking about some calculus with polar coordinates. So that's not too bad. But this video we're going to talk about graphing with polar coordinates. So we're just going to look at some common graphs. We're going to see what they look like, and hopefully we can see why they look like what they look like and stuff like that. So let's just hop into some examples. Our first example is A equals R sine theta and B equals R cosine theta. Let's remember that our sine theta equals y, so let's add a y here, and our cos theta equals x, so let's add an x there. Well, we can see easily that these are now just going to be straight lines. Let's say B is here, let's say A is here. Remember, B or A could be negative or positive. In this case, A is negative, B is positive. Remember, we still use x and y for our plots. R and theta are just a different way to represent it. It's not a completely different space. It's not like imaginary numbers at all. So, y equals A, horizontal line at A. X equals B, vertical line at B. Very simple. We've also got one more straight line, and that's theta equals some angle phi, where we're just going to draw our angle phi coming up from here, and then we've got a diagonal line coming down. So that's our straight lines. Let's get into some circles, and then we'll get into some more interesting, still circular shapes, but usually you're going to get circular shapes with polar coordinates. If we wanted to just graph those lines, we probably would have just used our regular Cartesian coordinates, or Cartesian graphing, like we talked about in Calculus 1. Straight lines, though, I mean, that was long ago. So, next we've got R equals some value A. This is just going to be a simple circle centered at the origin. We find our negative A, our negative A, our A. Don't forget your X's and Y's. And we're just going to get a circle going around, touching all A's. I apologize for the change in color, guys. The sun is being very weird today. But yeah, circle radius A, centered at the origin. Let's graph some circles that aren't centered at the origin. R equals A cos theta. R equals B sine theta. We're going to graph these on the same graph, and so that's why I used A and B. Remember, they could still be the same value. We know this, general algebra. But let's take a look at A cosine theta. Well, if theta is equal to 0, cosine is equal to 1. So we're just going to have a point of A on our x-axis. Let's say cosine is equal to pi over 2. Got a point of 0. So what we're actually going to end up with is a circle just like that. Very, very simple. And same with sine theta. We'll just have, remember, B could be negative 2. Boom. And A and B could be as big as possible. So that's circles for you. We've also got this interesting graph. R equals theta. Looks simple. Some of us might already be thinking about what might this look like. Some of us might already know just by thinking about it. We're just going to get a spiral. So that's a cool one. It's, of course, going to continue to go without bound. Unless we let theta run from some value. Then, of course, it would stop. But yeah, that's the spiral graph. I suppose we could also have an amplitude on theta or r. Let's take a look at some, I like to call these the peach graphs. Say r equals a minus b cosine theta. Let's draw our coordinates in again. We've got x and y. Okay, well, let's use what we just used. When cosine theta equals 1, theta equals 0. I guess I should have said that in reverse. When theta equals 0, so we're pointing this way. Cosine theta equals 1, we're going to have a point of a minus b on our x-axis. Easy. Cosine theta equals pi. We get -1. We get a plus b, but remember, we're at pi, so we're facing this way. So we're going to get a plus b over here. Remember, we're using our Cartesian coordinates to represent this. So what we're going to get is -a plus b on our x-axis. Next, let's say cosine theta equals pi over 2 or 3 pi over 2. So our spot's on the y-axis. What do we get? Well, interestingly enough, we just get a, since this whole thing will become, this whole section right here will become 0, since cosine theta is 0. 0 times anything is 0. So let's put a in here, and, well, the sun's changing again. We get an orange tint this time. Let's go like this. Oh boy. Oh boy. Okay. These shapes I'm not the best at drawing, especially when I'm not right in front of it, but you guys see the point. These come out to the same distance on the x-axis. Wow, that's one of the worst graphs I've ever drawn. Yeah. So that's that. Let's change it to sine. All we're going to get is that graph, but turned 90 degrees. This time I'll draw it before I put the points in, but, oh, I forgot my theta. I'm just not on my game today. But yeah, this is when theta equals 0 or pi. It's going to be 0, so of course we're just going to get the point A. We're going to get our point y equals, or sine theta equals 1 when theta equals pi over 2, so we're going to get a minus b, and we're going to get a negative a plus b over here when theta equals 3 pi over 2. Okay, let's look at a very simple yet different graph. I'm going to change this back to cosine. Hopefully I can draw this one better. A plus b cosine theta. What we're going to get this time is this. X, Y, Okay, so let's say theta equals 0. Cosine theta equals 1. We get a point of a plus b at a theta equals 0. We get a plus b over here. Okay. Let's say that theta, or we'll try to make this cosine theta equals 0. We're going to get theta equals pi over 2 or negative, or pi over 2 or 3 pi over 2, or negative pi over 2. I guess that's how I was thinking of it. So we're going to get a up here. We're going to get negative a down here. We're also going to get a point where we just get 0 right here. And we're also going to get a point b minus a right here. And so what we're going to get is this. I think I've drawn this one not very well to scale again. But yeah, like that. And I won't go over the sine one. We know that if we switch our cosines to sine, we just turn 90 degrees. We'd get the same thing. But yeah, that's graphing. I hope to see you in the next video where we talk about derivatives and areas, integrals with polar coordinates. Thanks for watching this one.